Discover the amazing, clinically proven health benefits of Original Tahitian Noni. Original Tahitian Noni includes powerful antioxidants, adaptogens, nutrients, and phytonutrients to naturally boost energy levels, immune system function, and overall health. Meticulously sourced from French Polynesia, this is the original superfruit. Accept no imitations. Original Tahitian Noni. Visit ATR Health at alchemicaltechrevolution.com. and click on the Shop Here tab for more details.
But we can no longer risk emergency improvisation of national defense. We have been compelled to create a permanent armaments industry of vast proportions. In the councils of government, we must guard against the acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex.
You're listening to the Alchemical Tech Revolution, and I am your host, Wayne McRoy. Good evening, good morning, wherever you are around the world. Tonight, we're going to discuss this concept of the Ethereal Hearth. Well, the hearth is central in the home. Of course, you know this. This is a concept that predates our modern times. The hearth always being central in the home. Well, what is this notion of the ethereal hearth? Well, we're going to look back at the early history of radio broadcasting, and we're going to discover that in the early part of the 20th century, the radio became very central to many homes in not only America, but within the developed world. This became a centerpiece in the living rooms of people all across America, and of course many other nations in the world. And this became one of the primary tools used not only to convey information in a relatively short time from place to place, but it also became one of the preeminent social engineering tools of modern times. And of course, this was the precursor to the television. The television, the greatest mind control technology ever devised. But the radio certainly had its place, and it still has its place. As a medium, radio broadcasting is still very much important. In fact, that's what I'm doing right now. Were it not for this type of technology, I would not be able to convey information to you in the way that we do so. So it is a useful tool in many regards. The problem is it's been misused in the past by the social engineers and the dark occultists who run things in this world, who have misused and misapplied this technology in order to socially engineer the masses. Now, we always run into these same problematic themes across the board with the development of these technologies. And my view, of course, is these are tools. They can be used for good or they can be used for bad. And of course, the early development of this was implemented by those who realized the potential to do bad things with it and capitalized upon that potential. And of course, the rest is history, as they say, and we're going to explore that history. We're going to be reading into a book once again, and we've read from this book on some previous episodes here. It's titled Media and the American Mind, From Morse to McLuhan by Daniel J. Czitrom. Now, this is actually a very good book. It gives you a good factual, fact-based history of the development of various things, and we did an episode prior about the motion picture industry. And this, of course, came into fruition prior to the mass adoption of the radio in the homes of the Americans. But you'll see there's some esoteric types of crossovers here when we're talking about the radio as the ethereal hearth. Now, this has been replaced in modern times by a new form of this ethereal hearth. And I would say, by and large, in the latter part of the 20th century, and, of course, the beginning part of the 21st century, the ethereal hearth that at one time the radio filled the position of has now been filled by the television. And I would say in the more recent near past, it's being replaced by computers and or screens, computer screens of sorts. The internet could be said to be the ethereal hearth of modern times, but we'll see how this takes on a type of esoteric connotation. Because when you think about the hearth, you think about this notion of warmth and centrality to the home. It's central to family, the family unit. And they've, of course, replaced the hearth with something different at this point. It's not something that necessarily brings about this feeling of warmth or community or companionship or love. These types of ideas have now been replaced by this synthetic device. And of course, in the early part of the 20th century, this would be the radio, and the latter part would be the television, and like I said, now it seems to be shifting more towards the computer being central to the home. And of course, this takes away the notion of human contact. Once again, you could see how these subtle social engineering agendas are playing out, and the subtle occult types of connotations play out with this, if you could connect the dots there. So certainly, we see that this notion of the ethereal hearth has become an important part of social engineering the masses in the modern era. And this has its roots with the advent of radio broadcasting, and we're going to get into that right now as we read from this book, and I find it compelling, and this is where I got the title, is actually from chapter 3 of this book, where it talks about the ethereal hearth, American radio from wireless through broadcasting, from the years 1892 to 1940. The development of the telegraph and the motion picture proceeded in a relatively straight historical line. Pioneers in the creation of those two media struggled to find technological solutions to specific problems. The transmission of intelligence using coded electrical impulses through wires and the perfection of projected motion photography. Early in their history, the implications those media held for prevailing notions of communication and culture seemed startling. And I'm going to pause there. So we had these inventions. Motion pictures, of course, we did a prior episode on the advent of the motion picture and how it influenced the world and changed the world in very many ways. And now we're talking about ways that these inventions, this along with the telegraph and other things, began to give credence to the possibility of instantaneous or near instantaneous communications across very long distances. So this is an important concept to keep in mind. They seem to think that this had potential for other types of uses. And of course, early on in the development phases of this, it was recognized by what would later become the military-industrial complex that this could be weaponized. So now we're getting into the crux of the matter here. Radio broadcasting added a totally new dimension to modern communication by bringing the outside world into the individual home. The history of radio, however, was far more complex than the histories of the previous media breakthroughs which we just discussed, motion pictures and telegraph, that would be. The broadcasting system tied together a bundle of technological and scientific threads that had been dangling for a generation. It thus makes sense to distinguish wireless technology up to and including World War I from the later system of radio broadcasting. Wireless technology presumed a far higher level of scientific knowledge, particularly in mathematics and physics, than that required by previous advances in communication. Although individual experimenters around the world contributed to wireless progress, it ultimately achieved technological sophistication through the research performed and coordinated by science-based industry and the military. And I'm going to pause for a moment there. And there is the big connection. The military, they recognized the potential uses this could have on the battlefield, or for the battlefield, for the greater war effort. And of course, the early advent of what would later become the military-industrial complex began to capitalize on this, and they were the ones that were most interested in figuring out how to use this wireless technology for themselves in order to achieve certain purposes. And of course, like everything else, this turns out to be a dual-use technology, first perfected for all its military applications and then unleashed to the public for commercial use. So we have this going on in the early part of the 20th century, just prior to World War I, up to and including World War I, where they were figuring out how to use radio broadcasting in various different ways. They recognized the potential for this wireless technology, and certainly the advent of things like the telegraph. This was hugely, monumentally changing of the way communication happened. So they used this in many ways, and it did transform the world in a lot of ways, but it was limited in its usage because, you see, you needed a wire in order to transmit information in that way. Whereas this newer technology of radio broadcasting, it introduced the idea of wireless communication. You didn't need this wire. It was far less limiting than the telegraph. So they decided to focus their attention and their resources into developing this technology. Radio broadcasting began as a marketing tool, a service designed by large electrical equipment manufacturers to sell privately owned receivers. The enormous potential of radio broadcasting for improving the quality of daily life, its ubiquitous power to bring art, entertainment, music, education, and news into the living room, contained severe contradictions. I'm going to pause for a moment. So it was introduced first as a marketing tool. A marketing tool. Now, the very beginning phases of the military-industrial complex took notice of this and decided they were going to try to develop these technologies themselves for other uses, militaristic uses. And we have this different dichotomy of thought. But here, it says here that it was begun for marketing purposes for things like the dissemination of entertainment, music, education, and news into the living rooms of people all around the world. It was a transformative tool. It brought information to people in a way that otherwise would not be available. And it became a replacement of sorts for a lot of the print media after it really had taken hold. Let's continue here, though. It says, because it's talking about some of the contradictions that were contained in this advent of putting a radio in every living room. With radio broadcasting, wireless technology went public in the privacy of the home. But if the ownership of receivers promised to be democratic, what of the control of transmission? During the 1920s, debate over radio's future centered on the question of structure and finance. Would the electrical interests supply the service indefinitely? If not, who would pay for it and how would it be regulated? By the onset of the Great Depression, advertising had established itself as the basis for American broadcasting. Critics wondered about the hidden social costs of free broadcasting paid for by commercial sponsors. Meanwhile, with its newfound stability, radio programming regularly featured hybrid combinations of traditional entertainment and news forms. And I'm going to pause for a moment. So the early uses of radio were primarily for military purposes prior to World War I, but then the full-on commercialization of it came out directly after World War I. And in the 1920s, they began to figure out who's going to foot the bill for this. How are we going to do this? who's going to be the broadcaster, per se? Who's going to take charge of that? Is it the electrical companies? Who's going to do it? And wouldn't you know, the industry itself decided how this would be done and how it would be paid for. And primarily it was paid for by commercials, commercial sponsorship. So companies would pay money to have an advertisement for their product and or service come over this new form of media to people for them to hear. And this would supply much of the monies that would prop up the infrastructure for broadcasting. And we have these different hybrid combinations which came forward from that. So in the beginning phases, it would seem the electrical companies and those who were supplying the infrastructure and perhaps building the radio sets themselves were the ones who were perhaps controlling the broadcasting at that point. But then, of course, like everything else, you have to get government involved at some point, right? And that's exactly what happened. It was all about who's going to regulate this? What kind of regulations are we going to have? Who's going to foot the bill? Who's going to be in charge of broadcasting? And I think this was a hotly debated topic at the time, because who were the commercial interests who were broadcasting on the radio? You see, it was kind of like the Wild West at that point. There were all kinds of different people who, if they had the technology to do so, if they had the devices to do so, they could broadcast or transmit radio signals themselves to be received on certain frequency bands. And there was little regulation in place at the time. Nobody necessarily owned any particular radio band or network or anything of the sort. So this is wherein everything began to really full sail roll out for consumer use. And of course, an entire industry arose around this, a broadcast industry, complete with regulatory rules and agreements. So this is what was established in the 1920s. So by the time the Great Depression rolled around, advertising was established as the basis for the funding of American broadcasting. And it does say that the commercial sponsors were pretty much the ones footing the bill, but were they the ones broadcasting? Let's see if we could garner some other information here. Looking backward, quite a few of the contemporary appraisals of wireless technology and radio broadcasting strike us as rather quixotic. This is in part because today's broadcasting media continually propound the idea that their current configuration is the only one possible. But the range of opinions on wireless technology's significance and the variety of proposals for the organization of radio broadcasting remind us that the present incarnation of broadcast media need not be permanent. And I'm going to pause for a moment, and this is a massively important idea that does affect us in the modern times. Just because they have their systems set up right now doesn't mean it has to still always remain that way. You see, there's always new incarnations of this cropping up. Like right now, I'm broadcasting right now live from my basement, from my little studio in my basement. And people are hearing this. And this is a different type of broadcasting from what the regular structure is. I'm not on a particular affiliated radio network or some cable news network or some such thing, or a broadcast news media channel or anything like that. I'm not on a mainstream channel that turns up on the radio, the terrestrial radio, or on the televisions. And of course, the regulatory process for all of this and the infrastructure was laid out and put in place starting in the 1920s, and we have the current iteration of it today that we have now that's largely accepted. But there are new ways of doing things, and many technologies have been developed and will continue to be developed that make it possible to do things differently. And thus, it makes it harder for the regulators to impose restrictions and rules upon certain types of broadcast media. So here I am, as long as I have an internet connection and you have an internet connection, I can broadcast and you can hear this. And we also have, of course, all the prerequisite recording software and everything that goes with it today, so this can continue to be replayed over and over again and heard by many, many people, whereas in the past something like this would not have been feasible. You would have to have the proper studio equipment, which in the early days of radio was likely a lot more expensive and elaborate, and you would have to have the proper way to do that. So it wasn't something that was accessible to most people. Now, with our modern technology, this is more accessible than ever for people. And I would say radio, as a broadcast media form, still has unlimited potential. You would have thought in the era of digital film and digital media that radio would have disappeared. You would think so, wouldn't you? But there's always been a market for it. Now, with motion pictures, of course, as we've stated earlier, and digital media and things of that nature, it probably has put a little bit of pinch on the overall radio industry itself. But certainly, people are listening to programs like this more now than ever before. With the invention of podcasting and everything that goes along with that, it made it more accessible for more people, more voices to be heard, more content for people to hear, rather than content just put out there through the approved channels that existed at one point, through the terrestrial radio stations, which are largely owned by major corporations, same thing with the television stations and all of that, centralized control of media. And we still have that to some degree today. But now we have these independent platforms that make it possible for broadcasters like myself to go out there and do this. And this is an important thing to keep in mind. And this is what the author here was talking about. The current incarnation of broadcast media need not be permanent. And certainly we're seeing shifts in the way things are done. And of course, the regulators are always trying to push back and figure out new ways to control this. And concurrently, with the regulators, you always have the advertisers, because you see, this was established very early in the history of broadcast media, that the advertisers would foot the bill, the brunt of the bill, to pay for all of this. And certainly we have the same thing going on today. In fact, a lot of podcasters depend upon, of course, ad revenue to help pay for the costs of broadcasting. Now, I'm no different in that regard. I do get ad revenues from various places simply out of necessity. But by and large, you won't hear ads on this show aside from an introductory ad, unless, of course, you're listening on certain platforms like YouTube, and they insert commercials in there, of course. And I do get a little bit of cash from them for that, not nearly what it should be. YouTube does not pay anything near what the standard rate is per capita in the rest of the broadcasting industry, for sure, with their advertisements. But they have a type of monopoly on video hosting, and that's wherein, in the modern era, you arrive at some various problems in that regard. And this is one of the ways in which they centralize control and regulation of this type of thing. But that's an aside for another time. That's a topic to explore some other time. I want to get back to the notion here of how radio became a preeminent part of the American lifestyle. And of course, how this, over the course of time, transformed into television being a cultural influence on the American people. Almost as soon as scientists perfected electromagnetic telegraphy, they began searching for ways to eliminate the wires. Both Steinhale in Germany and Morse in America demonstrated telegraphy by conduction, using the earth or water as a return circuit early in telegraph history. Later, various experimenters successfully telegraphed by forms of induction, using electrostatic induction, whereby an electric charge in one conductor induces one in another nearby. Edison in 1885 created a system allowing moving trains to utilize telegraph lines running parallel to the tracks without interfering with the normal message load sent over the wires. Edison's motograph, as it was called, tried briefly on railroad lines in the 1880s, and it proved a scientific success but a commercial failure. Using electromagnetic induction, in which an electric current in a wire, while increasing or decreasing, induces another current in its neighborhood. William Preece managed to send telegraphic messages over several miles of water. As chief engineer of the British Post Office, Preece conducted numerous experiments in the 1890s using parallel series of wires to maintain communication with islands inaccessible to the wire telegraph. And I'm going to pause for a moment. So, early bids at communicating were utilizing telegraph technology, and of course it had its limitations because it needed a wire or some type of a conductive medium to kind of, how should we say, piggyback the signal one to the other, a relay system of sorts. So it provided some limitations for communication, so certainly a wireless method of this would be preferable, wouldn't it? Despite all of this work, none of the conductive or inductive methods of wireless telegraphy demonstrated clear potential. During the 1880s and 1890s, nearly all researchers approached the problem as one of conquering water, communication between ships, between ship and shore, or between islands. Edison's curious motograph was the exception. For use over water, however, neither inductive nor conductive telegraphy could even replace the foghorn. Most observers agreed with the prognosis of the Harvard engineer John Trowbridge, who ended an 1892 review of various plans for wireless telegraphy at sea by declaring, quote, "Telegraphing through the air without wires by means of electricity does not seem at present to have the element of practicality in it," end quote. To Trowbridge, the question of wireless communication over land did not seem worth deliberating, and it probably would never be used even if it were practicable, according to Trowbridge. The ultimate scientific foundation for wireless telegraphy came not from induction or conduction, but from the concept of electromagnetic waves traveling through space. University-trained scientists, largely in England and Germany, pioneered in proving the existence and utility of these waves. In the 1860s, James Clerk Maxwell, one of the great theoretical physicists of the century, mathematically predicted the existence of electromagnetic waves in the ether. Gonna pause for a moment here, folks. That's right, in the ether. Now, ether physics has disappeared from the modern textbooks, most assuredly, and you dare not utter the word ether in the annals of physics these days. They will claim that they've discredited this, and that since Einstein's discoveries, this was largely dismantled as a reality, but certainly the existence of an ether seems to be preeminently displayed throughout all time and study. If you go back in the old natural sciences, hermetic sciences, it's an acknowledged feature of our reality, the ether. This is the substrate on which all of our physical manifestation exists. You see, Tesla told us to think in terms like this, that light is nothing more than a sound wave in the ether. So we need to understand the correlation between light and sound. They're both electromagnetic frequency bands. One has a different medium than the other. The medium of sound travels through the air, while the medium of light travels through the ether. That's why light can traverse a vacuum, because there's something else. It requires a medium. If there is a waveform that can travel, or I don't know if travel's even the right word. When you get back to the concepts that undergird ether physics, it's a perturbation of the ether. in which we see this. It's just like a sound wave. It's not actually traveling. It's disturbing the medium. It's disturbing the air. So when you have this vibration, it disturbs the air, and it doesn't truly travel. It just creates this ripple through the air, and it translates as sound to the human ear. So it's the same thing with light, but light needs a medium also in which to manifest in this way. So this is how Tesla described it, and of course there's a lot smarter people who have described this in much better ways than I can, but it seems to be a misnomer that sound or light, quote-unquote, travel in the way that they do. It's just a disruption in the medium. And of course, in this case, when we're talking about radio waves, or what we're familiar with as radio, we're talking about different frequencies of sound waves, and sound travels through the air or the water or whatever other physical medium that we have here that it goes through, or wires in some cases, as in the early telegraphy. But the discovery by the ether physicists, including James Clerk Maxwell, discovered that there's also perturbations that occur in the ether as well, and that these waveforms transcend through these different forms of mediums, whether it be the air or the ether. And this potential could be utilized if it's understood properly. So he made predictions on that. He made predictions about the existence of these electromagnetic waves in the ether, because certainly it could be demonstrated that it happens through air or some other medium like water, these kinds of things. So he made the prediction about electromagnetic waves in the ether. So let's see what else we could muster from that now. So both light and electricity, Maxwell showed, resulted from vibrations in the ether. They differed only in the rate of vibration. He predicted that electric waves could be set up by electric oscillations and, like light or sound waves, could be detected. These electric waves would travel at the speed of light. Although the notion of a mysterious all-pervasive ether later became discredited among scientists, it served Maxwell as a convenient fiction to help explain the presence and behavior of electromagnetic waves. I'm going to pause for a moment here, folks. So the author of this book seems to align his ideologies with what our modern physics shows, and that's fine. People can have differing opinions about this. It seems to me that if you go back to the understandings of ether physics, you have a better model to work from for how things truly operate in this world. That's just my opinion, and that's also the opinion of many other learned people, including Nikola Tesla, who seems to be the one who understood the electromagnetic spectrum the best. And I don't think there's too many others who've come along since then that maybe could understand this better than Tesla did. Now, there were some, and there probably still are some. I would say Eric Dollard is probably one of the modern people that has a very good grasp of this and how things truly operate. So if you want a better understanding of that, you can go ahead and listen to some of the things he's put down. It's interesting stuff for sure. And of course, as always, I'll cite Ken Wheeler, who actually wrote several books and various other materials about this and seems to have a very good understanding of the true nature of electromagnetism. So he's another valuable resource in the modern era that could give you a better clue as to what goes on with this, at least in my view, and the things I've seen and I've studied and I've looked at as well. It seems the ideas put forward by these two modern thinkers align with much of what I've found, especially that jive with some of these thinkers of the past, like Tesla, like James Clerk Maxwell, like some of the early ether physicists. And it seems it's a better model for understanding how things actually occur in this world. And this transcends just things like radio broadcasting, folks. I'm talking about the very nature of consciousness, the very nature of manifestation here in the physical world. It all ties together. And of course, it all ties back to the old Hermetic sciences as well. So there's a lot of different connections and ways of thinking about it, but certainly I think much has been lost in the modern era in regards to these ways of thinking. But as it pertains to the topic today, let's get back to the reading here. So it says, over 20 years later, Heinrich Hertz built machines to generate and detect electric waves, confirming Maxwell's electromagnetic wave theory. Between 1888 and 1892, Hertz performed a series of classic experiments showing that electric waves, like sound, heat, or light, could be reflected, refracted, concentrated, and focused. Throughout the 1890s, scores of researchers all over the world took up the intellectual challenge of exploring the wonders of Hertzian waves. Edward Branly in France and Oliver Lodge in England made great strides in perfecting the coherer. Branly discovered that loose metal filings in a glass tube, which normally have a high electrical resistance, would lose their resistance in the presence of electric oscillations, cohering and thereby becoming a conductor. Lodge added a tapper arrangement like that of a doorbell to Branly's coherer. Each successive impulse produced coherence and decoherence. The filings took the place of a telegraph key, allowing a recording instrument to receive messages. In Russia, Alexander Popov used a coherer attached to a vertical wire that was designed to record atmospheric disturbances and detect thunderstorms in advance. But none of these scientists had a clear conception of using Hertzian waves for regular wireless communication. Others in the scientific community, however, did see great potential for etheric telegraphy. In 1892, noting the investigations of Hertz and Lodge into ethereal vibrations or electric rays, British physicist William Crookes wrote, quote, "Here is unfolded to us a new and astonishing world, one which it is hard to conceive should contain no possibilities of transmitting and receiving intelligence. What therefore remains to be discovered is, firstly, simpler and more certain means of generating electrical rays of any desired wavelength. Secondly, more delicate receivers which will respond to wavelengths between certain defined limits and be silent to all others. Thirdly, means of darting the sheaf of rays in any desired direction. This is no mere dream of a visionary philosopher. All the requisites needed to bring it within the grasp of daily life are well within the possibilities of discovery." End quote. So that was from William Crookes. And he wrote that in 1892. So he basically just outlined what's necessary to make radio broadcasting possible. Now, they're thinking in terms of communication, first of all. But there's another property of all of this that lies just beneath the surface of what's being discussed here, and just what lies just beneath the surface of what's been devised and developed technologically in this world, and Nikola Tesla touched upon this in his work and his researches. You see, if you can wirelessly transmit information via a broadcast or radio wave, it is also not only possible, but probable that you can transmit electricity wirelessly. And certainly, this is what Tesla wanted to do. And those financiers who were supporting his work, when they found out what he was up to, they decided to stop funding him for this, because their whole concern, how do you put a meter on that? That was their concern. And of course, we're talking about J.P. Morgan in particular, and some others in general. But this was the whole notion that captured the imagination of Nikola Tesla. The wireless transmission of electricity as a usable form of energy. We're talking wireless energy. And he was able to demonstrate and do this. He had built a workshop somewhere near Colorado Springs, and he was able to light light bulbs wirelessly from a distance of 20-some miles, if memory serves me correctly, using just this transmitting tower he built there in an experiment. Now, he later developed these concepts a little further in his laboratory called Wardenclyffe on Long Island. And this is where he was beginning to develop the fundamental stages of the wireless broadcasting of electricity. And this is when J.P. Morgan stepped in and began to shut down the funding for the research, and Wardenclyffe shut down. And the tower that was there is no longer standing, but of course there is still some infrastructure there, and you can actually visit Wardenclyffe. You could arrange a tour there of the old shut-down Wardenclyffe. Now, that said, there's not much that remains inside, but you could walk around the grounds there. And I would love to go check that place out at some point, but at any rate, that's what lies just beneath the surface. We know, beyond a shadow of a reasonable doubt, that you can transmit a radio signal wirelessly. Well, this is just an electromagnetic spectrum frequency band of sorts. Electricity is also essentially the same thing. So it's just a matter of perhaps finding the proper way to attune the frequency band in order to wirelessly transmit electricity. And there are certain tech companies that are actually working on that and developing that right now, and have probably developed some working models of this. And of course, they're talking about now where you can, in the near future, buy a cell phone or something that you'll never need to recharge, because it will recharge wirelessly. They're working on these technologies. It's out there in the open literature. Now, this was all stuff envisioned by Tesla way back over 120 years ago. He knew what he was doing. He knew what he was looking at. And some of these early ether physicists also understood that precept. And you have to wonder, well, why did ether physics take a backdoor to Einstein's theories? And if we look at that convoluted time in the history of science and physics, we begin to see certain ideas pushed to the background and new ideas adopted in its place, which lead us into thinking in terms of a model of physics that doesn't seem to jive with the reality around us. So in order to make it work, they have to have two distinct models of physics. And they try their best to unify these models of physics into a grand unified model of physics. Of course, we're talking about, we have these notions of Einsteinian relativity and quantum theory, which seem to be the two major physics models that are at odds with one another right now. So you have the physics on the macro scale and the physics on the micro scale, and they're always trying to reify these two very distinct and different things, and they can't ever seem to make them jive. Now, if you go back and you look at the ether model of physics, there's no need to come up with all of these different mathematical reifications and ways of thinking in order to make these systems jive, to make the microcosm jive with the macrocosm. There's no need for that. Ether physics adequately explained things wherein our current models of physics do not. And I do think it seems very evident that within some of the black budget community and the special access programs of the military-industrial complex, they know this, and they know how to apply these different concepts that are derived from ether physics and develop technologies around those. So this makes me question a lot of things, but certainly this is something that's an important notion in the background of this development of radio as a technology. And that's why, even today, I am fascinated by radio. That's something strange that has kind of been enveloped in my personality from a very young age. I've always had a fascination with radio. Strange. And I never thought that it would play such an important role in my life as it does now. And it's interesting because this is actually something that runs through my family, which is strange enough. Now, my late father and we had a mutual love for talk radio. And this was something that I very fondly remember of him. And he actually gave me an old radio set that I have here in my studio behind me right now, that I keep here as a keepsake. It has some sentimental value to me. It's an old 1950s style radio tuner. And we've had this fascination with radio that somehow has transcended through our family generationally. You see, my grandfather, he was an old-time television repairman. I remember in his garage, he would have all of these television sets and radio tubes, and he would repair radio sets and television sets back in the day. That is what he did. And he had a fascination with this technology, so I find it weird, and I think it's something that runs through the generations in this way. Maybe it's that whole notion of genetic memory and this kind of thing. But I've always had this fascination with radio, and it's taken on such an important and prominent role in my life. So I'm still exploring these ideas, and of course you see all of these other related things that occur in the background with the development of these radio technologies. So this is something that is of particular interest to me, and I hope you don't find my little diatribe here boring, but certainly there are a lot of things we could still learn from the mechanics of radio broadcasting that could be applied if you just know how to think outside the box into other potential fields or modalities, if you want to put it that way. But let's get back to the reading here. So it says, Crook's article inspired the young Anglo-Italian Guglielmo Marconi to develop a truly practical wireless telegraphy based on Hertzian waves. In the popular imagination, Marconi's name is the most closely associated with the invention of the wireless telegraph, but this is a gross simplification. Marconi should be viewed as the crucial innovator in wireless, not as its inventor. By modifying, improving, and perfecting the devices introduced by Hertz, Lodge, Branly, Popoff, and others, Marconi achieved the best practical results in wireless communication beginning in 1895. Going to pause for a moment, and concurrently, Nikola Tesla was also developing these same types of ways of doing things as Marconi. And some will still argue that Tesla should be the one credited with the invention of the radio rather than Marconi. And of course, this is open for debate among scholars. It's all about who filed what patent at what time with what entity. All of these things were being developed pretty much simultaneously. So Guglielmo Marconi, he gets a lot of credit for it, because it would seem that his patents were the ones that were filed first, or are the ones that are more held out as actual patents for radio broadcasting as a type of a means of communication or a way of doing things, this wireless telegraphy, as it was called. And Tesla's patents were a little more generalized. Like, he had several different patents, but he didn't have the patents stacked together into the same performance of a task in the same way Marconi did. Now, I don't want to get off on that side tangent here, but let's put it this way. There's debate as to who should be the true father of radio. And you could argue all you want with this. So largely the one that came into the scientific realm as the accepted inventor of radio broadcasting was Guglielmo Marconi, by using the devices invented by some of these other people in conjunction in certain ways to get the best results. Unlike the university scientists, he had a clear idea for the commercial development of wireless. From the start, he surrounded himself with the best engineers for assistance, as well as top managerial talent. Although his own technical contributions were not radically new, Marconi applied for patents on all of his projects, thus making certain that his company acquired a dominant position. Taking advantage of his family's wealth and contacts in England, Marconi performed extensive experiments under the auspices of the British Post Office, and in 1897, with the backing of English capitalists, he formed the Marconi Wireless Telegraph Company. The organization planned to install wireless equipment on lightships and lighthouses along the English coast. Marconi's achievements in wireless communication over progressively greater distances attracted enormous attention from the scientific world and the popular press on both sides of the Atlantic. 50 years earlier, wire telegraphy inspired diverse theories about the nature of its driving force, electricity. All the work done with Hertzian waves fueled a similar, if more sophisticated, type of speculation on the nature of the ether. In particular, many scientists agreed with J. Ambrose Fleming, prominent physicist, engineer, and a later close associate of Marconi, who thought the theoretical import of wireless far more intriguing than its capacity to send messages. Its practical uses are indubitable, he wrote in 1899, but it has a wider interest from a scientific standpoint in that it opens up a vista of fascinating speculation into the possible revelations in store for us concerning the powers and potencies of the mysterious ether. Gonna pause for a moment here, folks. Now, the question comes to mind again. Why has this notion of ether been promulgated to the dustbin of scientific history, when this had such true potential of understanding and developing new technologies that could be massively transformational for the world? Well, who controls the development of these technologies? That's what we need to ask. And then you can begin to understand who has a financial interest in keeping these types of technologies just out of reach of the masses. Because if you think about it, if you explore this topic out to the depths of its potentials and possibilities, just exploring the concept alone of wireless electricity being a potentiality, this can be massively world-changing. Free energy available out of thin air for anybody to use who has some type of a device that's electrical that could access it. Think about that. How transformational could that be? The other thing is, how do you control access to this? If it's out there, if it's being broadcast through the ether, if you're broadcasting electricity through the ether, anybody with a potential proper receiver for that electricity can pick up that signal and use that. How would you control access to that? The only way would be maybe to sell a one-time use device that gives you access to that free electricity. And this is not very profitable for those companies in charge, is it? The ones that like to, get their energy from burning what they term fossil fuels and this kind of thing. The big moneyed interests, the ones that generate power by building these massive electrical power plants where they burn fossil fuels or they use some other means to produce the electricity, and then they have an entire infrastructure that they have to build and supply this to. This goes back to the old ways of thinking of the telegraph. It's a wired connection. You need to have this wired connection in order to send the electricity where it's needed. And this creates a monopoly of sorts by a small select few within an entire industry. Now, if that all goes away and we have free energy available to everyone, that is problematic for the people who control things in this world, because it takes away much of their wealth and power. And remember, wealth, as expressed in dollars, as expressed in the form of money, is nothing more but a measurement of social energy. It's about control. If you control the dollars, you control the people. Well, if they have no more need, if the people have no more need of access to the goods or services of that small select group of elitists who control things, then they have freedom to go about and do what they want, and they don't need the industry to prop them up. And they're not paying their wealth, their social energy, to that industry or the mega corporations that run that industry. And therefore, it's not a profitable business model anymore, and a lot of this falls down on that. Greedy corporations, that's one side of it, but when it gets down to the core of all of it, it's about control, and it's about control by those at the top of the power structure who steer and direct these various agendas and technological developments. So they don't want the masses to have access to this. But certainly, they cannot overlook the importance of the broadcasting of electromagnetic spectrum waves, or Hertzian waves as they were called here. And this is just one aspect to this that we need to explore. Because there's a whole model of physics that exists beneath the surface that's not expressed in the mainstream at all. This ether model of physics, which has better explanatory notions as to how things work, first of all, and second of all, the developments that could be garnered from an understanding of this could monumentally change the focus of the world, could change the direction the world's going in, and could end poverty, and end inequality, and end all of these problems that we have. But there's people at the top who have a vested interest in none of that coming to fruition, because it benefits them to have one up on the rest of us. Makes them wealthy, gives them a lot of privilege, gives them a lot of power and influence, gives them a lot of control of things that happen in this world. And they don't care about humanity at large, although they will profess that they do. And that is the true evil behind all of this, at any rate. But let's get back to the reading here. So it says, for centuries, scientists had postulated various ethers to explain phenomena as diverse as gravity, light, and the motion of the planets. The theoretical work of Maxwell, corroborated by Hertz's experiments, seemed to prove that all electromagnetic and optical phenomena could be explained by a system of mechanical stresses in a single ether. This all-encompassing ether of fixed position and finite density sufficed to transmit all the known forces, such as gravity, light, heat, and electromagnetism, that one material object exerted on another through distance. The ether hypothesis enjoyed a wide acceptance by scientists in the late 19th century. Development of the first wireless devices in the 1890s no doubt added to the prestige of the single ether theory. But when various experiments showed that the ether and its properties were unobservable, the notion of a material ether became untenable. And I'm going to pause for a moment here, folks. And here's what they're not telling you. Those experiments that supposedly showed that the ether and its properties were unobservable, well, they're lying about that. This has since been demonstrated that you can observe some of the properties of the ether. This is what the Michelson-Morley experiment was about. Now, here's the thing. They said the results Michelson-Morley got disproved the ether. Well, that's not necessarily true. And the Michelson-Morley experiment is regarded by some as a very important facet to the proving or disproving of the ether. Now, here's what happened. About 20 years ago or so, a group in New Zealand called Liquid Gravity decided to redo the Michelson-Morley experiment, but they turned the entire apparatus 90 degrees, and they were able to observe and measure an ether flow. And this is something that is important to consider, but you will very likely not hear about that anywhere. This was an important finding, because the Michelson-Morley experiment, when they originally did this, they had the apparatus positioned in the wrong way. And therefore, that is why people came up with this idea that it disproved the ether, when in fact, nothing could be further from the truth. But this is what the annals of history record. This is what we're told. And then we have this rise of Einsteinian theory here, and we're going to get into that now, because the author discusses this. So he says that the various experiments showed that the ether and its properties were unobservable, and therefore it became untenable. Now, just because something is unobservable doesn't mean it's not true, right? That's the other facet of this we need to keep in mind. But just like everything else, our modern science will discard it if it cannot be adequately measured or weighed or quantified, because they're all about quantifying the properties of a thing in order to prove their existence. If you can't quantify it, it doesn't exist, and that's the problem with our modern way of thinking, our modern science, more rightly called scientism. But let's get back to it here. So it says, by 1905, Einstein's special theory of relativity had shown, among other things, that there could be no single ether providing an absolute standard of rest, and that the velocity of light in empty space is always the same relative to any moving coordinate system. And I'm going to pause for a moment here, folks. Now, even in mainstream physics, this has now been disproven. The speed of light is not constant. It is not always the same. This has been disproven, and you would think this would be a big part of relativity theory, wouldn't you? You would think this would be a big defining block of information that would show that perhaps this theory is incorrect. But of course, they don't talk about that, do they? Let's read on. Oliver Lodge, the British physicist and wireless pioneer, offered this typical description of the ether. He called it, quote, a perfectly continuous, subtle, incomprehensible substance pervading all space and penetrating between the molecules of all ordinary matter, which are embedded in it and connected with one another by its means, and we must regard it as the one universal medium by which all actions between bodies are carried on, end quote. Now, I'm going to pause for a second there. The ether. You dare not utter that word in the realms of physics today. But of course, they still discuss this because it has to be present. There has to be a medium there, and they recognize this, but they won't dare call it ether. They won't dare talk about it in certain terms. They will, however, use a mathematical reification to describe it. Some will call it dark matter or dark energy. Einstein referred to it as the cosmological constant in his equations because, you see, even he had to account for it, even though he's said to have discredited it. And, of course, you have the modern quantum scientists, quantum physicists, describing this as the quantum vacuum or the 0 point. Understand this. Doesn't matter what you call it. It's still ether. It's there. They don't want to admit to it because here's the thing. If you go back to some of these older ways of thinking, going back to the science of the late 19th century here, discussing ether physics, you have a closer proximity of what things really look like and how they truly operate. And if you get too close, then you might actually make some discoveries that could lead to the fall of the empire. That's what it's about. And at the heart of all of this was the discovery of radio broadcasting. That's why it's a massively important topic. Wireless broadcasting, wireless energy, wireless radio. Oh, okay, so we just described what Oliver Lodge described this as. The ether. So throughout the greater part of space, one found simple, unmodified ether. Elastic and massive, squirming and quivering with energy, but stationary as a whole. Here and there, however, were specks of electrified ether that were connected by fields of force and in a state of violent motion. These specks were known as matter. For physicists, the ether theory provided a simple unifying principle. Ether was a basic category for understanding the physical universe. The vagueness of the notion, argued Lodge, will be nothing more than is proper in the present state of our knowledge. So I'm going to pause for a moment here. And this is what our modern science does not like about ether. It's kind of vague because you can't truly measure it because it is a substratum of the material world in which we live. It's not strictly physical. Now, it is described in the secret schools by the occult fraternities as being a sublayer of the physical material plane in which we live, the ether. But it's a much finer form of matter. It's much less dense, according to how they describe it here. Because you see, sometimes we lack the proper terminology or words to describe these things. It's much more fine. it's much less dense. And that's one of the terms they use in occultism to describe these various realms that exist around us and throughout the world here, the invisible realms that seem to be ever present, but can't necessarily be objectively quantified by our modern science. Ether falls into that category. So it's kind of vague. They can't deny its existence, but they also can't measure it objectively. So therefore, they deny its existence, even though they can't deny its existence. So they come up with mathematical reifications to explain it away. And sometimes they'll describe it as the quantum vacuum. They'll describe it, as I said, as dark matter or dark energy, and they'll find a way to work it into their system. Like I said, Einstein described it as the cosmological constant. What more can I tell you there? They have to account for it in their mathematical measurements and quantifications, but it's a vague quantity, so therefore it's hard for them to express it adequately, so they have to use a variable number for it, and that's what they don't like, because it is kind of a vague commodity, and they don't have an adequate understanding of how it truly works. Now, I think they've probably gotten a lot closer through the special access programs of the military-industrial complex of understanding perhaps some of the machinations of how it works, but they're not telling us about it, are they? Let's read on. But ether had important metaphysical implications as well, and these might eventually be grasped with the help of the new wireless devices. The feeling that the wireless had somehow put men on the threshold of the innermost secrets of nature paralleled that elicited by wire telegraphy. The relation between the wireless and ether stirred anew the old dream of universal communication, a dream expressed in religious terms by the early commentators on the telegraph. But with the wireless, the discussion drew its metaphors and vocabulary primarily from physics and biology. Conceptualizing and explaining just how ethereal telegraphy worked proved no easy task for scientists. We have been so trained to regard currents of electricity as something flowing in one unbroken circuit, wrote William Preece, that their temporary condition as waves of energy in space is hard to realize, especially in the absence of an electrical sense. But perhaps in the coming ether age, man might evolve a new electrical sense through his knowledge of electromagnetic waves. Oliver Lodge argued that we are growing a new sense, not indeed an actual sense organ, but not so very unlike a new sense organ. Electroscopes, galvanometers, telephones, delicate instruments these, not yet eclipsing our sense organs of flesh, but in a few cases coming within measurable distance of their surprising sensitiveness. And with these, what can we do? Can we smell the ether or touch it? Or what is the closest analogy? Perhaps there is no useful analogy, but nonetheless we deal with it, and that closely. And I'm going to pause for a moment here. So is it true? Are people developing some type of a new sense of sorts? Well, think about this. There are people who are sensitive to electromagnetic spectrum frequencies. You probably know some people that get relatively sick if they approach a 5G tower or if they are in a heavy Wi-Fi network area. They know it's there. They can sense it, and perhaps it has some ill health effects on them. Maybe there's something to this. Is this a type of an acknowledgement of the ether? Are we developing some new sense about it because of the inundation of the world with these new electromagnetic frequencies that hadn't been around prior? Who knows? Let's continue reading because now it gets interesting. Telepathy, perhaps the ultimate form of universal communication, might follow from a better understanding of the ether, the universal medium. Among others, the American physicist Amos E. Dolbear postulated that since different kinds of motion in the ether generated heat, light, electricity, and magnetism, scientists might soon be able to manipulate the ether to produce thought transference with brain waves. Going to pause for a moment, folks, and are we indeed just about there? I would say probably. Let's continue, though. The English scientist William Ayrton told Marconi that his new method of communication seemed almost like dreamland and ghostland, not the ghostland of the heated imagination cultivated by the Psychical Society, but a real communication from a distance based on true physical laws. If the ether theory straddled the physical and the metaphysical, most scientists found this fact more ironic than preposterous. After all, the ether theory had gained greater credence precisely because of the latest discoveries of scientists in the field of the wireless. Oliver Lodge noted that natural philosophy must sometimes be forced into a conviction about something intangible and occult. And I'm going to quote from him here. This is Oliver Lodge, quote, "And when next century, or the century after, lets us deeper into their secrets," and he's speaking of electricity and ether, "and into the secrets of some other phenomena now for the first time being rationally investigated, I feel as if it would be no merely material prospect that will be opening on our view, but that we shall get a glimpse into a region of the universe as yet unexplored by science, which has been sought from afar, and perhaps blindly apprehended by painters and poets, by philosophers and scientists," end quote. So that's an interesting quote. So he's foreseeing that perhaps sometime this century, now he was speaking in terms of the 20th century and perhaps the following century, the 21st century, that's now, that we would be coming into perhaps this new knowledge of how things work. And I think we're at the precipice of this, folks. It's just a matter of those structures in this world that have been built and implemented and put in place to protect the elitist class, this very wealthy subgroup that sits astride the top of the power structure in this world. Once those things begin to fall, then perhaps we'll have a better understanding of the machinations of how things truly work in this world, and perhaps we'll have a better future, a better way forward. We are living in the times of revelation, the veil's being torn away, and I don't think it's any different with this. A lot of the scientific developments have been hidden away from us by these military-industrial complex special access programs, the black budget community, the deep state, whatever you want to call it. It constitutes a breakaway civilization of sorts that has been hiding some of these innovations from mankind because it does not benefit them to let them out to the public at large. That, I think, is the important prospect to all of this. But let's get back to it. And this is just showing you, why is looking at the history of radio so important today? And what about this concept of the ethereal hearth? The hearth, the center of the home. And how can it be reached? Through some unknown, invisible medium. And how could it be influenced? And certainly, you could see this psychological underscore of how that's been done by manipulating radio broadcast media to influence human behaviors, and later, of course, television, internet, social media, all of the things we have today, all of these different forms of communication. Communication being key here, because they're communicating in ways that we scarcely even realize with some of these technologies. You see, it's not just a direct conversation back and forth, or a exchange of information or a broadcast of information. There are unconscious things being conveyed through this, and subconscious things being conveyed through this. This is something that transcends the conscious mind into the unconscious realm through this ethereal hearth, because these carrier signals can sometimes have other spiritual connotations attached to them, some intentionality attached to them, things that are not easily quantifiable but certainly do exist. And disregarding the spiritual component of things is what our modern science does all the time. But the intention is also embedded in the signal, and that's why I think this author presciently, whether he realizes it or not, called it the ethereal hearth, the radio. Let's continue, though. In 1902, Marconi succeeded in signaling across the Atlantic by wireless telegraphy, fueling further excitement about the possibilities. Two areas of service opened up in these years: the purely commercial sending of messages and the selling or leasing of equipment for the marine wireless. By 1905, the Marconi organization alone had outfitted hundreds of naval and commercial vessels and had set up 50 land stations around the world. At first, the Marconi companies sold equipment, but they soon adopted a policy of selling communication like the telephone company. They leased wireless sets and provided a Marconi-trained operator who communicated only with other Marconi-equipped ships or shore stations. Going to pause for a moment here. So now you see, early on, they figured out how to monetize this, even though, technically, if you just produce the device and sell it to the buyer, and you have other buyers who have the same devices, then ostensibly you would think they could just use the device and communicate one with another. Well, no, that does not generate long-term revenues. So this is what they had in mind in the developing of these technologies. How are we going to keep making a buck off of this? And it's sad that that's the state of human affairs. When we have something that could be as transformational as this, it's become an industrial property. It's become commercialized. It's become incentivized. It's become a cash cow. So this is what happened with the early Marconi company. And we'll see how this crosses over into military and intelligence realms of things when you look at it here as well. Let's continue. In the United States, the British Marconi interests launched an American subsidiary that soon dominated the wireless field. Other companies began in America at this time, spurred on by government patronage. The U.S. Weather Bureau hired Reginald Fessenden, a Pittsburgh electrical engineer, to conduct experiments in wireless as an aid to forecasting. In 1902, Fessenden formed the National Electric Signaling Company, and he later became a leader in the development of wireless telephony, I guess is the proper pronunciation, the wireless telephone. Lee DeForest, the other important American wireless inventor, formed the first of several wireless companies in 1901. The next year, the government commissioned him to build experimental wireless sets and stations, providing desperately needed funds. Later, DeForest became perhaps the preeminent American inventor of the pre-war era, and his Audion vacuum tube proved crucial for both radio transmission and reception. Gonna pause for a moment here, folks. Now, some of this is more familiar type technologies for some people who understood the early workings of radio. This is where the tubes, the vacuum tubes, come into play here with all of this. They were an important part of this. Now, we're so beyond vacuum tubes at this point that it seems archaic to think about, but these were some of the important early inventions that made this type of thing possible. The major technical problem in these years was the perfection of syntony, namely the tuning of wireless devices so that a transmitter could communicate with one receiver to the exclusion of others and vice versa. The point-to-point model of the wireless stemmed from the military implications that many saw in it. Of course, the military implications, right? As early as 1897, Marconi himself had pointed out the military potential of wireless telegraphy for exploding gunpowder and the magazines of ships from a distance. He clearly had military uses in mind when discussing the urgency of improved tuning. Others noted the prospects for steering torpedoes, firing mines, and blowing up forts with radio waves. Gonna pause for a moment here. So now all of these implications are here as well. Think about this. They're talking about using radio waves to destroy targets, to explode gunpowder, and the magazines of ships from a distance, steering torpedoes, blowing up forts with radio waves, the Tesla death ray, which is a reality, by the way. All of these things were discussed early on, as being potentials in the military-industrial complex for this. Now, of course, this was the early phases of the military-industrial complex. It really didn't come to full manifestation until sometime around the Second World War, surrounding the Second World War. This is when the military-industrial complex, as we know it properly today, really came into fruition, came into formation unto its own. Now, some of its roots could be traced back to World War I as well, but this wasn't really truly what we would accept in the modern era as the military-industrial complex at that point. Now, this is when everything began to become interconnected, is during some point in the phases of World War II, when it all kind of came together and everything kind of cycles through the military-industrial complex now before it gets out there for public consumption. Now, at this time, this was kind of a mixed bag with the early invention of radio broadcasting. It was out there for marketing uses, for commercial uses, and the military picked up on it and decided to run with it and do different things. And of course, Marconi had military uses in mind, as he pointed out here. So let's get back to this, though. The point-to-point model for the wireless did not, however, preclude non-military uses. The perfection of tuning would ensure the secrecy of different kinds of messages. Ray Stannard Baker, who reported on Marconi's achievements in 1902, thus projected a not-distant future where organizations and even families could secure their own private frequencies. Great telegraph companies will each have its own tuned instruments to receive only its own messages, and there may be special tunes for each of the important governments of the world, or perhaps, for the system can be operated very cheaply, the time will even come when the great banking houses and business houses, or even families and friends, will each have its own wireless system with its own secret tune. Having variations of millions of different vibrations, there will be no lack of tunes. The English engineer William Ayrton offered an even more personal vision. Eventually, everyone might possess his own wireless transmitter and receiver. I'm going to pause for a moment here, folks. So think about your cell phone in your pocket. All of this predicted way back in 1902. They understood what the potentials were for this. And honestly, some of these things were probably developed much sooner in secret than what we acknowledge in public. Cell phone technology, they certainly had this very far back, going back to at least the 1970s or 60s. Bare minimum. They actually had this technology available then within the auspices of the military-industrial complex. It just hadn't been widely rolled out on a grand scale as of yet, so the infrastructure was not quite there to make it practicable at that point. But they certainly had developed the technologies. And this is something to think about. So here's what William Ayrton said, quote, "If a person wanted to call a friend he knew not where, he would call in a loud electromagnetic voice, heard by him who had the electromagnetic ear, silent to him who had it not. 'Where are you?' he would say. A small reply would come, 'I am at the bottom of a coal mine, or crossing the Andes, or in the middle of the Pacific.' Let them think of what that meant, of the calling which went on every day from room to room of a house, and then think of that calling extended from pole to pole, not a noisy babble, but a call audible to him who wanted to hear, and absolutely silent to him who did not." End quote. Indeed, a critical new factor entered the wireless scene in the early 1900s, very much in the spirit of Ayrton's fantasy: the amateur wireless operator. All over the nation, thousands of amateurs, many of them schoolboys, constructed wireless receivers and transmitters, mastered telegraphic codes, and claimed the ether for themselves. The discovery that several types of crystals would serve as cheap, easy-to-make detectors of radio waves launched the amateur boom around 1907. By 1917, over 8,500 amateurs operated transmitting stations, and between 200,000 and 300,000 had receiving sets. A burgeoning cottage industry of electrical suppliers and wireless publications sprang up to cater the amateurs' needs. The rapid spread of the wireless art among amateurs vitally affected the evolution of radio. In the short run, the amateurs contributed to the ethereal chaos by interfering with naval and commercial service, thus making the need for government regulation more imperative. Going to pause for a moment here, folks. Here's the justification for commercial regulation of the radio channels. And in a more recent note, just a few months back, California banned shortwave radios. You're not allowed to have a ham radio in California anymore. That's my understanding. Why is this? They don't want people, perhaps, taking things into their own hands, having ways to communicate with one another that go outside the bounds of the control system. They don't want people to figure things out or to develop new technologies themselves. They don't like tinkerers, folks. Let's put it that way. They don't like anything that goes on outside of the auspices of their immediate control. Thus, they have centralized many of these developments to large corporations that subcontract to governments to develop these things, and intelligence agencies and military intelligence agencies, places like DARPA. They subcontract out to some of these major corporations who develop some of these cutting-edge technologies. They don't like tinkerers with workshops in their garage that figure things out on their own and produce effects that are unsanctioned by those arbiters of what is the most state-of-the-art, quote-unquote, science of the day. People like John Hutchinson, they don't like those people, so they will quickly do their very best to snatch those people up and get them under their employ, or to shut them up in one way, shape, or form. John Hutchinson, if you haven't heard of him, folks, look him up. He did some interesting things in his garage. Let's put it that way. You could still find some of the videos on YouTube, others not so much. But at any rate, they don't like those types of people, and they don't like when people begin to tinker and figure things out on their own, and that's why they had to put regulations in place, because you see, in the early days of radio, there were a lot of amateurs out there who figured out how to build radio sets and transmitters and receivers, and they were actually out there interfering with the commercial bandwidth and the military bandwidth of this. They didn't like that, so they had to set up regulation. So in the long run, amateur wireless sets provided an invaluable training ground for future researchers and broadcasters, and these hams formed the first audience of the earliest radio broadcasts. Government regulation of the wireless began in this period with the report of the Roosevelt Board in 1904, which recommended a three-way division of authority over the American wireless. The Department of Labor and Commerce would supervise commercial stations, the War Department would have charge of military stations, and most importantly, the Navy would control coastal stations. This report, though not law, established the dominance of the United States Navy in the wireless field, enabling it to build its own systems and pour millions of dollars into research. Congress later passed laws requiring ships to carry wireless equipment and operators, but not until the Radio Act of 1912 did the government produce a comprehensive plan to regulate the wireless. I'm going to pause for a moment. So up until 1912, it was like the Wild West. That's right. So they could not have this going on. They had to regulate everything and take control of this means of communication, because you cannot have control over a population if they have an unfettered means of communicating one with another, with the free expression of ideas amongst themselves without some type of oversight. That's what they've done. The Act divided the wireless spectrum between ship, coastal, amateur, and government frequencies. It also gave the Secretary of Commerce broad but contradictory powers. He could assign wavelengths and time limits on stations, but he could not refuse to grant a license. This act remained the fundamental radio law until 1927. It did not mention broadcasting, yet it would serve as at precisely the time that broadcasting began. thus contributing to the confusion that characterized American radio in the 1920s. Just as wireless telegraphy appeared to achieve a semblance of stability, two interrelated developments, one scientific and one political, intervened: wireless telephony and World War I. Scientists had worked on the transmission of speech without wires since the turn of the century, trying to overcome several obstacles: the generation of uniform high-frequency electric waves that were sufficiently continuous to transmit the upper harmonics of speech, a means of modulating the electric waves in accordance with sound waves, a continuously responsive receiver sensitive to speech, and the linking of wireless and wire telephones by means of suitable relays. Early experimenters in wireless telephony often found themselves so far ahead of contemporary practice that they needed to wait for years until engineering realities caught up with them. By 1910, both Fessenden and DeForest successfully transmitted speech and music by wireless, startlingly wireless operators who happened to be listening in. Fessenden pioneered in the use of a high-frequency alternator for the production of the continuous undamped waves required to transmit the human voice. DeForest patented the three-element vacuum tube, or audion, which could be used both to modulate received radio waves and to create high-power waves in transmission. The perfection of wireless telephony became largely a function of research and development by several large corporations and the federal government. Private enterprise and government enjoyed forces on this project. They even joined forces on this project, Private enterprise and government joined forces. That's one of the early phases we see here of this relationship between the military-industrial complex, government, federal agencies, and big business, right? American Telephone and Telegraph, wary of possible competition, directed a massive research effort. As Frank Jewett, chief of the Bell Systems Laboratory Research, recalled it in later years, it was clear to the AT&T company that a full, thorough, and complete understanding of radio must be had at all times if the art of telephony was to be advanced and the money invested in that service safeguarded. In 1913 and 1914, AT&T bought all patent rights to DeForest's audion and related inventions, and it soon possessed all patents and patent rights covering the use of vacuum tubes in wire and wireless telephony. So I'm going to pause there. So this is how the whole industry became commercialized. AT&T was at the heart of it, as was Bell Labs. The Naval Department was in there as well. You have all of these different connections across the military community, across these big businesses that wanted to monopolize the field. So we have all of this cooperation that had gone on with these early inventions here that made radio broadcasting feasible. Now, we're going to close up here. The radio mania of the early 1920s began in response to first regular broadcasting done by station KDKA of the Westinghouse Corporation. I'm going to pause for a moment. So now you have your answer. Who were the early broadcasters? Well, Westinghouse Corporation, of course. The electrical companies, they were the ones who early got involved with radio broadcasting, but we'll see that this soon shifted, and entire other corporations came into existence that made their sole purpose broadcasting. Westinghouse executive Harry P. Davis noticed that amateur broadcasts from the garage of an employee, Frank Conrad, attracted attention in the local Pittsburgh press. A department store advertised wireless sets capable of picking up Conrad's wireless concerts. The ad, Davis later wrote, caused the thought to come to me that the efforts that were then being made to develop radio telephony as a confidential means of communications were wrong, and that instead its field was really one of wide publicity, in fact, the only means of instantaneous collective communication ever devised. In the fall of 1920, the company converted Conrad's amateur station into a stronger one at its main plant. Starting with the Harding-Cox election returns, it began regularly nightly broadcasts that were probably heard by only a few hundred people. After its wartime conversion to the production of radio equipment, Westinghouse found itself in the economic doldrums when peace came. Shut out of the RCA, GE, AT&T axis, it aggressively promoted broadcasting as a service that could sell cheap receiving sets and give the company publicity. Seizing the initiative in broadcasting enabled Westinghouse to enter the corporate alliance of the Radio Group in the spring of 1921. It bought 20% of RCA and would share the manufacturing of receivers and parts with GE. Going to pause for a moment here, folks, and this is how multinational corporate conglomerations come into being. This is demonstrable yet again here. So you have Westinghouse merging with portions of RCA and GE to produce the equipment and run the broadcasting. And this is how corporate interests get to steer and guide public discourse in this world. You see, they're the ones providing the broadcasting service. They're the ones building the equipment. The war is over. So their profitability from developing these things for the use in the war effort, they needed to shift. They needed to pivot. That's a popular word they like to use in business. So they pivoted. And they decided, hey, this could be way more profitable and have way more potential than just this guy broadcasting out of his garage and getting the attention of a couple hundred people. So they decided, let's turn this into an industry in and of itself, this broadcasting industry. So they began to sell the equipment and manufacture the equipment in conjunction with these two other big players who developed these things. And see, after the war was over, much of their capital that they had, much of their wealth that they had coming in began to drop off because the military wasn't buying up the products like it had been. So they needed to shift. And they shifted their focus towards broadcasting. Westinghouse devised this and combined with these other major corporations to make it a thing. So they formed this first radio network of sorts called KDKA. Immediately after KDKA started its service, scores and then hundreds of broadcasters entered the field. By May of 1922, the Commerce Department had granted over 300 licenses for broadcasting. At the end of that year, the number stood at 570. Tens of thousands of people began purchasing receiving sets and accessories. Swamped by this unanticipated demand, the radio group manufacturers struggled to produce radio equipment for the new audience and the legion of broadcasters. New and often shady companies sprang up to help meet the demand. Newspapers and periodicals around the country printed special radio supplements, eagerly accepting their share of the new industry's advertising. The public bought about 100,000 receiving sets in 1922 and over 500,000 in 1923. Total sales revenue from radio receivers and parts reached $136 million in 1923. And that's a lot of bread, folks, especially in 1923 dollars. Early broadcasting did not proceed as an independent commercial enterprise, but following the lead of KDKA, instead became basically a merchandising offshoot. The first broadcasters divided into three classes: those selling radio sets, those seeking goodwill and free advertising, such as newspapers, hotels, and department stores, and religious and educational institutions. For example, of the 570 stations licensed in 1922, radio and electrical manufacturers owned 231, newspapers owned 70, educational institutions owned 65, and department stores owned 30. The turnover rate was high, with 94 stations having shut down already by the end of 1922. Although some of these stations purchased their transmitters from the patent allies, many more bypassed the radio group and had theirs built by zealous amateurs, thousands of whom had received radio training during the war. At first, all these stations operated on the same wavelength, 360 meters, wreaking havoc in the air, particularly in urban centers. Secretary of Commerce Herbert Hoover, saddled with new obsolete Radio Act of 1912, called a series of 4 annual radio conferences, These began in 1922 and aimed at attaining some semblance of regulation. Broadcasters, manufacturers, amateurs, and researchers gradually worked out ways to allocate the broadcast spectrum. In 1923, the conference divided the stations into three classes: high power, later called clear channels, designed to serve large areas and be free of interference; medium power, often sharing time; and low power, which are local stations, all on the 360-meter wavelength. The programming in these first years included a broad variety of material. Regular shows were rare in the early 1920s, and most stations depended on phonograph records, popular and light classical music performed live by local talent, and talks such as storytelling for children. For example, the early program logs of WHA, a pioneer station of the University of Wisconsin, reveal radio programs on nearly every imaginable topic. Faculty members, mostly on a one-time basis, gave dramatic readings and talk on music appreciation, gardening, electronics, and history. Such talks became a staple in radio, particularly on the stations run by universities. On station KDKA, musical concerts, singers, and phonograph records predominated, along with rudimentary news reports and remote broadcasts of church services. KDKA, like the other stations owned by radio manufacturers and dealers, also featured lectures on technical aspects of radio. These were aimed at the nucleus of early broadcast listeners, the wireless amateurs. Itinerant vaudevillians began to perform on radio stations during these years. Singer Wendell Hall, one of the first of this group, performed in stations all over the country, often without fee, as a means of boosting the sales of his records and sheet music. Hall attracted thousands of fan letters wherever he went, a testament to the publicizing power of radio for entertainers. And that's how we got to where we are today. Anyway, the early history of radio is a very important subject for us to explore because it gives us a foundation upon which the later social engineers built. They realized the potential of this technology. They utilized it to the utmost. And we see how it's been commercialized, how this draw of wealth, the accumulation of wealth through the use of this technology, became a predominant part of it, and how advertising took hold. And of course, if you're exploring the field of advertising, you're talking about propaganda. Advertising, marketing, propaganda, they're all one and the same thing. It's just the delineation of how it's used that gives it its nuance. So this was well understood by the early practitioners who put these things together, and they very quickly turned it into an industry. They put regulations on it. They put government oversights on it. And from there, this regulation began to expand more and more. And the cost to broadcast became more and more. But these things have now been transformed in the modern era. Now, it does not cost nearly what it did at one time to broadcast. You see, we're coming full circle again. The early days of radio broadcast, it was like the Wild West, and there were a lot of people out there just broadcasting. And now we've seen kind of a renaissance of that occurring in the podcast era. Don't we? It's the same kind of thing going on. And of course, we could learn from our history and see what way that early radio went to know what's coming in the near future. How there's going to be more regulation, and as new developments occur, they're going to regulate all the more, and you're going to have vested business interests who step in, big moneyed interests who monopolize certain ways of doing things, and you're always going to have this kind of thing going on. But the important point here is they utilized it as a social engineering tool. And they took advantage of the fact that this now, for the first time, introduced the idea to the masses at large of having a receiver in their living room, their own Ethereal Hearth right there to receive broadcasts from. And this is how every household in America, and, well, almost every household in America, we should say at some point, has been infiltrated by those who control the flow of information in this world. They got their foot in the door. This happened with the advent of radio, and it has transferred over to television and to the internet and the computer and social media and all of that stuff we have now. They got their foot in the door, and now they are forever here in our ears, feeding us information and also feeding us propaganda and social engineering. And these things are changeable, and we are seeing a renaissance of that in the podcast era, like I had said. But even that's not without its troubles, because you see, you have to play by the rules of whoever's hosting your podcast now. Unless, of course, you host your own and serve your own audio and or video out there, which is becoming harder and harder to do because there are strict regulations on internet traffic, and there's only certain things available that you can get, certain domain names and such like that, and certain broadcast platforms you could use to actually reach a high number of people. So it gets more challenging. So these challenges we can overcome with this, but we're back to the grassroots with this podcast era we're in now. Much like it was in the early days of radio, where you had a lot of people out there that were just interested amateurs out there broadcasting. Same thing going on today. Just looks a little different. Our technology is a little bit better than what it was at that point with it. But it's the same thing, but we can't lose sight of the potentials here. And there's a lot of potentials. A lot of potentials. But the whole point here is the early phases of radio began to be monitored and controlled by a small group of regulators who decided what was going to be and how it was going to be. And then it was later weaponized against the people, the minds of the people. Once they got their foot in your door and they had their radio set in your living room, then they could inundate you with information. And then you have the radio groups that came about later, some of these study groups, the Princeton Radio Group, who performed broadcasts like the War of the Worlds and actually did scientific studies on people's reaction to that, and this is available in book form as well by a gentleman named Hadley Cantrill. He wrote the book about it and gave the study results. It was a project, folks. It was a work. It was a social engineering project. And this laid the groundwork for many of the social engineers of the modern era. They knew what they had a hold of here. This technology had a whole lot of potential to influence a lot of people's ways of thinking, and they only doubled down on that. So that's the important point. Like I said, there is also this occult side of it. The hearth, the center of the home, associated with love and with family and with comfort, with something very personal, intimate. Well, they've ensconce themselves in your intimate space. That's what the whole esoteric premise of it is. Your mind. And that's the point of the etheric or ethereal hearth. So there you have it, folks. But that's all the time we have for tonight. I want to thank you all for tuning in. I want to remind you all I appreciate each and every one of you, and we'll catch you next time. Have a good one now. Discover the amazing, clinically proven health benefits of original Tahitian noni. Original Tahitian noni includes powerful antioxidants, adaptogens, nutrients, and phytonutrients to naturally boost energy levels, immune system function, and overall health. Meticulously sourced from French Polynesia, this is the original superfruit, except no imitations. Original Tahitian noni. Visit ATR Health at alchemicaltechrevolution.com. and click on the Shop Here tab for more details.
But we can no longer risk emergency improvisation of national defense. We have been compelled to create a permanent armaments industry of vast proportions. In the councils of government, we must guard against the acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex.